So, I'm Gemma, and I have a slight obsession, possibly unhealthy obsession with writing tests. And while I know the fact that this is odd, I don't think it should be so odd. And I want to kind of convince you guys the fact that while you may not find it, I don't necessarily find it fun, but I find it satisfying, and I think you guys should find it as satisfying and as motivating as I do. So my original plan was I was going to do the why you should test more, how you can start testing, and possibly slightly more importantly, why your boss should let you do more testing. But I actually ended up getting here at midnight last night because a test that some tests that I'd written ended up creating a real amount of trouble, and so I was up working with my boss until 10 o'clock last night in London. So I'm a little bit pan-fried. So I wanted to add in an extra section about the pitfalls. Sorry, I'm going to move over here because I keep standing in front of the square. So the first bit is about the why. Now, for those of you who don't know what this is the green tick you will get on a pull request in GitHub when all your tests have passed. This should make your life, this is a very happy, nice, satisfying feeling, or at least it should be. What it means is the fact that whatever your continuous integration system, whatever your build server is doing, it's come back fine, you're good to go. But why should, more than that, why should it matter? Okay, slightly fun left. The first time I kind of realised the fact that I needed to think about testing not just as I'm in a big company, we've got time to do testing, but I've got to start doing it on everything, was I did some freelance work a while back for a childcare booking site, and they dragged me back in to do a half day's work on an export functionality. And I did the work, thought it was all working fine, and I didn't notice the fact it had broken everything. Part of the fundamental reason why was the fact that I hadn't touched that code in 2 years. I had a certain mindset when I was designing the export, certain assumptions, and those were not anywhere near my current thinking or my current mind. So, if you've got time to test, if you've got time to test away at something, fine. If you've got time to fix something and then reset, then time to excessively test everything, then great. But most of the time you don't. You need to do some work. You need to know the fact that that your work hasn't broken anything, and then be able to push it out. So the actual real why. Kind of these are the three things I could get down to were the fact that effectively you can be more confident. Your code is actually going, because you're expecting code to be tested, you're actually going to start writing better, more rigorous code. It's not necessarily a conscious thought process I've found, it's just happened over time where I'm noticing the way that I develop has slowly changed over. And this is something else, it's all dependent on whether you do pull requesting as far as development goes on a team. If you don't, why don't you? Who does pull requests when they're doing development? Who doesn't? That's perfectly it depends on the size of your team, but even I actually do pull requesting on my own personal projects just to see what I've changed, even if I'm the only one working on it. The biggest problem with getting to do as much testing as I want is this one. And I'm very lucky at the company I'm working for at the moment, where I've been working there a month, and I spent about 3 weeks of it writing, fixing, and improving tests. And it was really nice to expect my boss to come down on me come down on me like a ton of bricks, and say, actually no, it's been useful because the whole code base isn't tested. It also means that you're understanding the code base better. But fundamentally, why it should matter in any environment came down to these fundamental reasons. The most recent example of developing faster was I was dealing with some slightly horrific lambda-based code that a developer had written. I came to a situation where a very opinionated developer had been my predecessor, and he'd written some really horrible to understand code. I generally try and avoid lambdas, just for a matter of course, unless they actually are very readable. One of the things I fundamentally believe is the fact that your code should be, it doesn't matter how much a senior developer is, if I give my code to a junior developer and they can't understand what it's doing, it's bad code. That's kind of the philosophy I try to live to. So I was trying to rewrite what he had done, working with outputs I wasn't entirely sure, wasn't able to necessarily wasn't able to thoroughly understand everything that was going on, because it was going up to the JavaScript layer that was then being handled by two other people's layers of JavaScript. So what I ended up doing was I wrote out tests to be able to check the current outputs, rewrote the code out into a much more sensible for loop that would actually explain what it was actually readable, and then I could add in the extra functionality I needed. But before what could have probably taken me the better part of a day, I was able to write tests in an hour and then spend an hour trying to decipher this lambda. So honestly, even though it may seem like you're having to spend more time doing tests than you'd like and you can't knock things out, over time you will write faster code. Next thing, kind of, deployments could cover going to QA, going to beta, and obviously going live. But fundamentally, if you're more sure about your testing, if your tests are in place and passing, then you can't be 100% sure that something's going to work, but you can be a lot more confident. And the final one is, if you're working in a team, is the fact that you know that if you've got a test suite in place and you're doing work, you can be reasonably convinced the fact that you're not going to break work that other people are working on, including at the merge point. That will come with a very big asterisk, obviously, but at the same time, I would feel that, my experience has been where there hasn't been testing and you're working with, unless you're working with two people who are, unless you are a clone of the other person and you think in exactly the same way, you're going to have a certain amount of conflicts in terms of what code's doing, what changes happen, and if you've got the tests in place, you're going to be able to work better together. So, next thing was how to just get started testing. I mean, I'm sure lots of you guys are already doing basic testing, or even more sophisticated testing. But I was thinking sort of some words that are not necessarily, these are all very test-specific words. So, unit testing is where you're trying to focus on a single piece of code, and you're trying to basically make sure that this specific thing is actually working. So in the case of a module that is doing mathematical computations, you would actually want to go down to the level of does the bit that pulls out the sorry, I'm just thought back to the most sensible way to go. You're literally wanting to test at the level of does basic addition happen? You don't care, you're not trying to, if you're caring about, well, how do I get to the point where something's adding, that's kind of the problem. You want to focus on the specific component, each specific component. One of the ways you get to do this is a technique called blocking and patching, where in your test environment you're able to effectively replace other components of the system with known good results, and inputs. So you can just test the specific component. When you're not doing that and you want to test the entire system, you have integration testing, where there's a certain amount of questioning whether integration can cover the entire package, or it can cover the entire package and also interfacing with the real world. The separation. I do realise I've just, because I kind of covered that, could also be called end-to-end testing. Regression testing is actually something you should need to do a little bit less of, and I will explain why. Is effectively, if you have fixed a bug, your test should now cover that behaviour. And if something breaks it down the line, you should see it breaking down the line. But I will come back to that when I'm a little bit further down. Finally, coverage is, I haven't necessarily come across any technologies doing in other languages, but I've mainly focused on Python testing. It's literally the principle of, there's a couple of ways of doing it, but essentially what it is doing is checking what percentage of your code base is being tested by your tests. So it will try and go to, it's looking for almost the error, it's looking for every single fork, every single error is a part. If that's happening, then you're getting 100% coverage out. If it's not happening, then you're going to get obviously a lower percentage. So I kind of thought along the lines of, if you just wanted to get started, the most basic thing that I do on every single one of my projects now, who's familiar with Pylint? So, for those of you who aren't, Pylint is effectively static analysis of your Python code. The reason why I said about Django developers is there's a certain tendency to, because Django reloads models and settings and everything else like that, that you're already doing that. It's not safe to rely on that because obviously it's not really owning your views and any other utility classes you're doing. What you should be doing is your very basic testing should be checking every single code, every single file that you're working with or could be editing. The same thing with your basic integration testing. You should be. One of the projects I'm working on at the moment is a data science, basically scraping Twitter data for location information for inferring movement patterns in disaster areas. Now, the only test I've got in place at the moment, because I've got 120 things I'm trying to work on with it, is I have the end of my build process, I just check the fact that the front end comes up and the fact that it's successful and there's the correct text on there, the fact it hasn't errored out. I have a lot of other stuff I want to be able to do with the testing, but at least then I know the fact that when my build has happened, the fact that because I'm building a Docker environment, it's been going up into my servers, at least the fact that the very basic functionality is deployed and it's running is happening. The fundamental thing that I find is the fact that it can be it's very easy to feel intimidating when you are starting out testing a new code base or starting out testing at all. You don't need to say, how do I get to 100%? Start out with 100%. Generate a coverage report. Start out at 0%. That's okay. If you haven't got any tests, that's a good place to start. And work upwards from there. I probably should run a statistical check, but if you look at the coverage reports on most large projects, they will not have 100% coverage. They will try to get better, they will try to avoid getting worse, but if you're dealing with any significant levels of code, you're going to run into a situation where having sufficient coverage is tricky. There will always be things you can't necessarily test. I kind of feel like this is just a very basic, simple test I kind of pulled out of. So one of the projects I did a couple of years back was, I'm sure most people have heard of Vine, probably don't necessarily want to know too much about it, but we were using it I was doing a social media application, working for a social media application company, and Vine doesn't have an API. Well, they now have somebody has now reverse engineered a, based on the mobile clients, an undocumented API. But what I came up with was a scraping library that, the way that Vine actually works on each of the video pages is it uses template injection and passes a JavaScript object in. So what I did was I wrote a library, a very simple library that goes onto the page, grabs that blob of, technically it's JavaScript, evaluates it, and then returns you a Python dictionary. That was something that was useful work, but what I wanted to do for me was I wanted to kind of do I will test this in every way I can think of. So this was one of the very simple tests I did, where I'm testing the bit which just does URL extraction. So if you check out, what the patching is doing is it's replacing the primary function, which is the bit that actually goes away onto the site and extracts the data out. There's a higher level one, which is where you take give them the Vine URL, get the Vine ID out. So all I'm doing there is just checking the fact that I know what the Vine URL is, I know what the Vine ID should be that it comes out, just check the fact that's happening. Testing doesn't need to be more complicated than this. It should literally be, here is a condition, here is what the output should be, and you can, if you're focusing on just that level, there can be a lot of complicated stuff in the beginning, I realise that. I've got some truly horrific testing code I've had to implement recently. But, sorry. The last thing on this one was the fact that I have such an untested code base. Somebody actually gave me some very good advice on this a year ago, where I was working on it wasn't a legacy project, but it was 3 years of development. Everything new we were doing was tested. And I was very happy with that, and I kind of thought, that's okay, because we're going to come back and fix everything else. What we ended up doing, this friend of mine actually said was some very good advice. Every time I was working on the legacy code base, write a test for the current behavior, then break the test by saying writing for new behavior, and then fix the code to fix the test. It can feel like it's slowing you down, but at the same time you're slowly, iteratively increasing the amount of testing you've got on your code base. And also at the same time you can be much more certain in the fact that your changes are doing what they're meant to be doing. So quickly onto the pitfalls. So coverage, which I lauded earlier, it can be a trap. The trouble is, if you've got one test that is supposedly checking your whole code base, it's kind of a false response. It's kind of a false result. What you really want is each test should be testing a smaller chunk of the. If you've got 100%, if you've got 50% of the 50% coverage for each one of those percentage points is a test, that's generally far better than 100% coverage of one test, because you're getting that precise checking each service is happening. The reason why I was working late last night was the fact that the test data I was working with was faulty. Your test will only, what I was effectively doing was I was maintaining I was checking, given the calculations we were working with, what was erroring, what wasn't erroring, and what the results were, which on the face of it sounds like a good state. And as we improved things, things would get better. Problem was, what was actually in the system when I was doing the initial state was completely wrong. So always check the fact that when you're doing your tests, what you're basing your testing data, what you're testing on, is correct. Is inconsistent data states. This is something I've found. I don't know whether particularly with where you're doing fixtures and testing, there's sort of a presupposition the fact that the database will always go back to the identical state before the test. Not always the case. I was going through a situation, and one of the fundamental ones is with Postgres and IDs. If you're ever making assumptions about what ID is in what place, and sometimes whether or not it's an ideal situation, that was the situation I had to deal with where I was making positional assumptions based on IDs. You will, each successive test will all be higher up the order, so what I ended up doing was doing relative positioning. But when a test may work on its own, doesn't necessarily mean the fact it will work as a group and it will be a pain in the neck. Database tests will always be slow. There are ways to speed it up, parallelization, sometimes you can do some clever tricks, but it will always be something that will slow you down. One word of advice. This may have changed, but I once spent about a month trying to mock out the Django RM. I got somewhere. Just broke horribly. And I suppose the final thing was just a when not to test. I'm very much a fan of remembering the line in F8. A foolish consistency is the hobgoblin of little minds. Testing is meant to make your lives better. If testing is basically, and this comes back to the mocking thing, this comes back to mocking the Django RM framework. If it's basically killing the project in order to try and fix something, then to a certain extent the testing is not working, and therefore you don't focus on testing it at the expense of actually doing the development. So I don't suppose I'm probably not in time, but any questions or on complete?
We've actually got plenty of time for questions because nobody's in this room at lunchtime. But yeah, so if you want to ask questions, then stay a while.
Would you be able to expand on coverage testing a little bit?
So, in the sense of how
it works, tools to use?
Primary one that I use is those tests for coverage, which those is an extra test run within which extends the PYCON test. There are other ones, but it's fundamentally running a secondary package called coverage, which is then generating a report. I've actually, if you want, I can show you. Yeah, I can show you what the coverage report looks like.
Great, thank you.
I have a question because, I was working with my manager getting a model to develop, and that model has unit tests, integration, and coverage. But it's for the exposure to companies that type of test, so I usually have to work extra time because it's mechanical testing. And I want to convince the group that we do the testing because the other code is not testing. So you have any tips on how I could do that? Because I'm just junior developer that's trying to make the whole
yes.
I mean, one of the ways I've gone about it in the past, have you ever heard, it's slightly used at the time, have you ever heard of the term cover your ass file? It's something that I was once sent to a management course many years ago, and it was one of the things that took me away is the fact that anytime things are going wrong, just make you write things down. What I would almost say is, every time something that comes up that should have been fixed by that this is a problem that testing would have caught, note it down and say, this is how much time it took. and actually start building up a record of this is how much time we're wasting by not focusing on testing. And I think, I mean, it's not a surefire way, but the thing is, sometimes it's just a case, that's just like it's almost the nuclear option side of things, where you've actually got to bash the manager's head against the desk to say, this is why we should be doing testing. But at the same time, if you can demonstrate, if you can demonstrate where testing is also actually making your development happen quicker, again, that's the same. That's the a good for a project manager. The fundamental thing is it's more about the project manager than the is it the project manager you're dealing with, or is it the boss you're dealing with?
It's almost the whole group, even my own colleagues. I try to convince them, and they don't want to because I don't know, because there's not this practice in the group to do so. So it's really difficult meeting to convince seniors of doing that, and convince my manager and the group manager, almost everybody.
I mean, generally it's a case that you've got other developers on site, but at the same time, the usual situation is you're generally got to convince that you haven't got all the legwork, particularly. I never think about that. If you find me tomorrow, I will have a bit more time to think about that.
So you have two worst group answers for that. If you're using Python, you're not testing, you're going to need a work.
So we have integration tests, but that's all.
There's still lines in there. You can go like, if you do bar's not there, you'll never see it until you get to it. Another thing, testable code is fantastic code. You don't have singletons, you don't have molly, block, whatever you call it, static. If you can test your code, it's much more code if you can't test it.
Yeah, I
So
know that.
just the ability to do that, and if those two arguments don't,
Yeah, I know that. The problem for is convincing the rest of the people in my
that
group.
should be enough.
I think one of the things I think that when we've lacked tested, the most apparent was when critical tests, we want people doing tests. The time between the dev team releasing that build and then finding that error or those things just failing can be literally weeks. So then we're doing another. So then we're going back and we're doing another one, and then we're going back and we're doing another one, and that's something that is at least very visible. So managers can see when you're on release candidate 5 and release candidate 1 was 2 months ago. So that's it. So I don't know. I think at our place, I think that's one of the things that makes it's easy to understand for that division. And so if you then say, so I'm going to have 2,000 tests which run in 2 minutes. Which would have found that and that. That's for me, that's one of the main values. It's the time.
I think one of the biggest troubles with time I find is the fact that, particularly if you've got any kind of, at the moment, our test suite currently takes 20 minutes to run, and it's a real pain in the neck when you're trying to do. What I've ended up doing is I've actually ended up setting a couple of other boxes up. So that they will then run I can then push the latest code up, run the tests on those while I can keep developing locally. And it's just been it's a pain in the neck, but it's one of these troubles, particularly when you're doing database intensive tests. The other thing I've started doing is when I actually can show you guys an example of it. So as I said, that was some of my lovely positional code. So what I've ended up doing here is because the state to get in for each one of those tests will take a fair amount of time, what I've ended up doing is doing each test sequentially, storing the state, and then doing a single assert at the end on whether I've got any errors returned back. So what I'm doing, there's 150 rows worth of testing test results. But I can do, effectively, I'm only having to do one data. The state is identical. It only works where the state is identical, but in that case, I only have to run one database creation, state change, into the right situation, and get the results out. If that makes sense.
Your database with a giant dictionary. So you can actually live record the database responses during a session into just a giant dictionary, and then just use that. I've used that in the past.
With Django or?
No, you just put a layer between Django and whatever you're using.
Okay.
Just as a recorder, and then it's off a recorder and just with a giant dict in there, and just use that instead.
We've just come to the recruitment session actually.
Oh.
We're going to be running. Have you guys finished yet?
Yes.
Someone said you were Oh yeah, carry on. You know, we're just set up in the corner or something. Ignore us, don't worry.
Ignore us as well, and then it'll work out fine.
Yeah. We can break out in that bit where we were just going to put into this room. Oh, perfect. Brilliant. Comes in so far.
Okay, so this is an example of what you get out from coverage removal. This is a library I've recently done this doing remote implementations. And so what you're effectively at the top level you're getting to figure out which is what coverage percentage is, breaking down to different files, but then what you can actually do is you can go down into you can actually see which specific lines, in this case it's just 2 errors that I actually haven't found a mistake to look. Well, to a certain extent, I wrote these with the intention of catching functionality that would basically, if I started doing it, it's an extended reverse Polish notation interpreter, and I would put these in the case of doing stuff that involves negative square roots and so it's tricky to get actually call those. So there's no functions I'm using that actually cause those. So
they're really
yeah. But
so it is you go and you access, you check how things like being active. And that's
and the one thing that's kind of useful to, at this point, is also then go back and actually make sure you run each individual. The problem is in the default mode, whether it's actually giving you which current test which ones. There is a setting off the top of my head, I can't remember which one it is, but it will then actually tell you how much of it is being run by each test. Or the poorer solution, but the easy one is you can just literally say, here is, just run this specific test, get this coverage out.
So I don't know how well I'll be able to